Have you ever wondered how radar works and how it functions? In this video, we are going to talk about radar and its principles and everything there is to know about it. The electronics principle that basically a radar works is sound wave reflection, and the best way to simplify this radar principle is that if you go on a rocky canyon and if you hear echo, that is sound wave reflection. So time required for echo to return can be roughly calculated and converted into distance if speed of the sound wave is known. So what does the radar uses? Electromagnetic pulse. In much of the same way, since radar acts as a both transmitter and receiver, it can transmit the signal as well as it can receive the signal. And while seeing the basic block diagram, which we'll be discussing later, we'll be understanding how a radar can be both used as a transmitter and receiver. The following figure shows the operational principle of primary radar set. The radar antenna illuminates the target with a microwave signal, which is then reflected and picked up by a receiving device. The electrical signal picked up by the receiving antenna is called echo or return. The radar signal is generated by a powerful transmitter and received by a highly sensitive receiver. As you can see on the figure itself, all the target produces diffuse reflection, that is, it's reflected in a wide number of directions. The reflected signal is also called scattering. Backscatter is the term given to the reflection in the opposite direction to the incident rays. Radar signal can be displayed on the traditional plane position indicator PPI or the other more advanced radar display system. A PPI has a rotating vector with the radar at the origin, which indicates the pointing direction of the antenna and hence bearing of targets. Transmitter. The radar transmitter produces the short duration, high power RF pulse of energy that are into the space of the antenna. Duplexer alternately switches the antenna between the transmitter and receiver so that the only one antenna need be used. This switching is necessary because the high power pulse of the transmitter would destroy the receiver if energy were allowed to enter the receiver. A receiver amplifies, demodulates the received RF signal. The receiver provides video signal on the output. Radar antenna. Antenna transfers the transmitter energy to signal in space with the required distribution and efficiency. This process is applied in an identical way on reception indicator. Indicator should present to the observer a continuous, easily understandable graphic pictures of the relative position of radar targets. Radar screen in this case is a PPI scope displays the produce from the echo signals and bright bulbs. Longer the pulse were delayed by the runtime, further away from the center of this radar scope they are displayed. The direction of the deflection on the screen is that in which the antenna is currently pointing.